Alright, in this video we will talk about Lewis dot structure. Uh, Lewis was the name of the scientist. He said that since the chemical behavior, that how element is going to chemically react, depends on the valence electrons, because valence electrons are the outermost electrons. So if sodium has 11 electrons altogether, if you look at the sodium has atomic number 11, mass number 23. So out of those 11 electrons, 2 are here, 8 are here, so that makes it 10, and then 1 is here. So how sodium is going to react depends on the number of electrons sitting outside in the valence shell. Okay, the valence electrons. So he said since valence electrons are that important and chemical properties depend on the valence electrons, why not take those electrons and show them as a dot around the symbol? And that's called Lewis dot diagram or Lewis dot structure or Lewis structure, however you call it, because Lewis was a scientist. So let's look at the periodic table, how many valence electrons we have for each element. For main group elements, which is these metals and these metal non-metals, for main group elements it's very easy to calculate the valence electrons. Okay, we have 13, 14, 15, 16, 17 and 18. So how many valence electrons each group has? It depends on the group number. So you have 1, 2, 3, 4, 5, 6, 7 and 8. So let's look at the iodine. Iodine is sitting right here. That means iodine has 7 valence electrons. So Lewis said, let's take the symbol of iodine and we will have 7 dots around it. And this is how you're going to do. 1, 2, 3. It has to be in 4 corners. 1, 2, 3, 4. And then you start pairing it up. 5, 6 and 7. It does not matter you go this way or where you start from. But what matters is that if I see something like this, okay, it is considered wrong. So it has to go in 4 corners. All you're doing is that you have to see where iodine is sitting in the periodic table. Iodine is in group 17. That means it has 7 valence electrons. If it has 7 valence electrons, you will just draw 7 dots around the symbol. Now boron is sitting right here. So boron has 3 valence electrons. It's right here. So boron has 3 valence electrons. So you go 1, 2 and 3. Again, it does not matter where you start from as long as you have 3 in 3 areas. So let's look at carbon. Carbon is sitting right here. So I go 1, 2, 3 and 4. Let's look at calcium. Calcium is sitting here. So calcium has 1 and 2. Let's look at neon. Neon is in group 8. So you go 1, 2, 3, 4, 5, 6, 7 and 8. It has 8 valence electrons. So maximum valence electrons can be 8. Keep it in mind. Maximum number of valence electrons will be 8. So it will not go beyond 8. Keep that in mind. I don't want to have like silicon. You can have 1, 2, 3, 4. There are like 14 electrons sitting here. This is not how it goes. It goes maximum 8. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8. So this is how you do the dot diagram or Lewis dot diagram. So hydrogen, this is group 1 and 2, then 13 and 14, 15, 16, 17 and 18. So anybody in group 1 has only 1 dot. Okay, so this is how you do the dot diagram. Group 2 has 2 dots. Right, we go 1 on one side, 1 on the other side. Group 3 has 3 dots. So that means they have 3 valence electrons. Okay, so this is how you do the dot diagram for 1 through 20 elements. You need to know how to do this and how to calculate it. That's about it for dot diagram. So draw the dot diagram for all these elements as well, and I will check that in the class. All right, that's all for the dot diagram.